Hey guys, what's up? Eddie Aho here with KissAnalog.com. I'm going to do a multimeter review, okay? This is a really cool meter I just kind of stumbled on. I didn't know Amazon was making meters. And so I just picked up the cheapest one just because I wanted to see what it was all about. And we're going to open it up. I'm going to end up opening up the, the unit too. We're going to look inside this bad boy. You know what's really cool about this thing? This is under 15 bucks. It's under $14, I think it was. I'll put the price here, put the link down below. And by the way, that helps me when you use those links, okay? Helps the channel and all that stuff. This is UL listed for under 14 bucks. That's crazy. Now, I was kind of surprised when it came in this little small box because, you know, it's hard to see scale when you're searching Amazon, but, you know, there's nothing wrong with that. It's just a little small meter. And I was looking at the other meters I have, and the one that most closely resembles is this little dude. This is a Trip Light. Well, it's called a Byte Brothers, but I think it's owned by Trip Light. And it's a BBT 858L. So it's close to this. This one's 20 bucks, $19.99 on Amazon. So less money. Anyway, I'm gonna kind of show them side by side just so you can see how it compares to something in its price range. But I haven't looked at any voltage or done anything that's still in the package. I've just kind of looked at it, but I don't know, man. It looks pretty solid, so I'm kind of excited. All right, guys. The accuracy of your meter, the biggest factor is how many digits. 4 digits, 5 digits, 5 digits that you can see when the light's on. 3.5 digits, okay? There's only 3 showing here, but it's 3.5 digits. That's the most important thing about your accuracy of your meter, okay? Now, I want to just talk about a little bit. I don't really do a lot of measurements like resistance, current, voltage, and checking accuracy because I believe that a lot of these meters are using similar chips, chipsets or whatever, and the accuracy is going to be there. I don't know if I see where the accuracy is not, unless it's just a bad meter. But anyway, so if you're really concerned about your accuracy, you want to buy a meter with more digits. And today we often use counts, like 3,000 counts, 6,000, 2,000 counts, like these guys, which are really $19.99 counts. Byte Brothers, I think they talk about theirs and they list as $19.99. Amazon calls this 2,000 count. Some people just say that, but it really is meaningful, whether it's 2,000 or $19.99. Let me show you why. So the accuracy has to do with how many digits you have, and obviously the basic accuracy of that display or that you know, that measurement, okay? So the basic accuracy, let's say for this range from 1999, for 19.99 volts and below, it's 0.8% and 2 digits, okay? So what that means is these are the digits I'm trying to show, 3.5 digits. So the one on the far left is half a digit, just 2 segments. These are supposed to be 7-segment displays. It's my artwork. First digit, second, third, and your half digit. So 3.5 digits, okay? Well, if you're reading 19 volts, you got 19.00. But if you're reading 20 volts, all of a sudden it shifts over because that can't show it to. So it comes over this way. Now you lost a digit. That's resolution. Has to do with your accuracy, right? That's the resolution. So an auto ranging versus, say, a manual ranging, you know, depending on what ranges you have and how many ranges you have within a voltage type. Like, let's say, for instance, these 2 meters that we're going to be looking at, on the DC they have multiple DC voltage ranges, but on the AC they only have 2. So imagine if you're extreme end, if you're reading, say, something like this, 1 volt on a 20 volt range, then your accuracy is not going to be that great, right? So that's an important thing to think about. If you're reading, like, let's say in 19 volt range, 0.8%, your voltage, if it was, say, 20 volts or 1999, it could be between 19.82 and 20.18. But now, if all of a sudden 20.18 is not going to show up in this, it's going to show up in this. So now your measurement actually changes, and because of the 2-digit counts, which means you add plus or minus 2 digits on the end, now it can go up to as much as 20.3. So you can see how much that changes just because it changes ranges. That's resolution. So you got your accuracy, still 0.8%, and then your resolution based on how many digits you have to have, and then the accuracy of that last digit. Okay, so if it's 2 counts, there's meters, and actually in these meters, I think it's resistance or something, it's 20 counts. So that means that you go 2 here, add 2 to this one, plus or minus 2 to this column, and 0 on this one, so 20 counts. Some are 30 counts. I've seen, 30 counts pretty commonly. Less than 1% accuracy is pretty common for meters. So when you are seeing 2 meters being compared, like we're going to do here, what I like to do is go on this border where it switches. If it's a 2000 count, do here, our 1999 count. If it's a 6000 count, then generally this is a full digit, so it can actually be 6000. An interesting thing I like to show on those kind of meters is what happens around there. Some of them behave a little differently, and that's where I think is more meaningful than the accuracy of the meeting, comparing that, because I don't know when we see that they don't meet their accuracy ratings, but how they behave in these, where they switch over from one resolution range to another resolution range, that's, I think, more important. So I like to point that out. And so we'll do that in this review, okay? So let's go do it. Okay guys, let's just go over a quick list of the features between these two multimeters, the Amazon and the triplet, the Byte Brothers. Okay, they're both 3.5 digit, 2000 count compared to 1999, so makes a little difference there, right? When you're close to the borders. Anyway, continuity, this one, anything from 30 ohms and down will give you the beep. This one, we'll find out. We'll use our pot back here to find out what that is. But that's an important thing to know. Does it give you the beep at 20 ohms, 50 ohms? And what if you get a beep and you got 25 ohms and you're thinking, oh, I'm near 0. You're not. That's just continuity. It's just showing, oh, you got a pretty low ohm connection. That's what that means. So just be aware of that. If you really want to make sure you're under 1 ohm or something, you got to actually put it on an ohm measurement and look at the ohms, okay? So just be aware of that part of it. I think they both have the 200 milliamp and 10 amp fuses. We're going to look to see which ones they have. Now, the one thing is this is UL listed, so should be able to trust this. This is CE, you should be able to trust this as well. This one's had another party look at it, and give the listing, so might be a little bit more trust, but they're both good names, right? No one wants to get in trouble by not saying they meet all their specs. So now I got the tolerances here. You can kind of see they're pretty close. The Amazon actually ekes out, looks a little bit better, especially here, 2 digits compared to 4 digits. Now where they're different is the triplet has temp and BJT, the HFE measurement. Some people kind of make fun of that. What's wrong with that? Some people with audio want to match transistors, so might be a cheap way to do it. So yeah, I don't see a problem with the BJT tester. I've always kind of liked having at least 1 meter around that did that. Anyway, and this one does battery checks. I like that. Now, they both will check voltage on a battery, of course, but you know what? When I wrote it down as battery checks, it's probably not what it's officially called, but what that does is it puts a little bit of a load, because the battery can kind of peak charge, and when you put just a little bit of a load, it just pulls it right down. You guys have seen that where, maybe where you've measured the voltage on a battery, you put it in a device, and it works for a minute, and then stops working, and you measure it again, and it's a lot lower. You're like, what the heck? And so you load the batteries and test them that way. Let's go test. All right, so testing. I'm going to use this this guy here, the 5-digit meter. Okay, and it's got the high pot, so I can go. I think it's 125 volts, 250, 500, and up to 1,000 volts. So I can test dielectric breakdown. So I think we'll use that. Hopefully we don't damage anything. If we do, well, wasn't a good meter in the beginning, right? Okay. I don't expect to find any problems doing this, by the way, but all right, it'll be fun. All right, guys, so let's open up this bad boy. Amazon commercial, 2,000 count, and look at this, UL listing. Alrighty, yeah, nice little meter. Okay, hold on a sec, let's just take out the probes. All right, so with the little booty here, it says Cat 3 1000, Cat 4 600. That's what the leads are made for, not the instrument. Pop it off, Cat 2 1000 volts. Okay, that's the probes, like I say. These are kind of soft. Some of them are harder. These are a little bit easier to take on and off. Now, when you are around the higher cat ratings and you kind of want these booties on there because you don't want arc between these two things, so you want to limit the exposure that an arc can occur in a category 3 or category 4. So yeah, so these guys are actually a good idea. Now it says 10 amps, and it's nice because they actually have the label of the wire on. It says it's 18 gauge, 2000 volt, 80 degrees C. I don't think it's silicone, but they are nice. They're fairly soft and flexible. I've seen these probes before. They kind of have that triangular grip, which, you know, is pretty nice. And it's pretty grippy, so you're not going to accidentally slide off. And these guards keep your fingers back, and having a nice grippy thing helps that too. And the shape, the triangular shape, I think kind of helps as well. Okay, so enough about the leads, right? Okay, Amazon battery. All right. And our meter, no manual. There we go. Wow, it's fairly thick. Okay, it starts off with English. And you know what? It's never a bad thing to kind of peruse a manual, because I've found things that the meter does that I wasn't aware of, or maybe a warning that I maybe wasn't aware of. And the fuse sizes are in here. 600 volt fast flow, 200 milliamp, 10 amp. Okay, anyway, we got a manual. Stick that back in the box. Okay, let's put a battery in this. And well, okay, first impressions. Let's just take a look at this. I mean, it is a solid, very rigid construction. That is completely solid. UL listing, fuse information here, double insulation, the double square thing up there. Stands easy enough to get out. Looks like 2 screws for the battery and 4 screws to open it up. So it's the 90 DM120. Backlight, hold. Yeah, it's pretty nice. Okay, milliamps over here, amps over here, and Cat 2 600 volt. So even though the meters are well, you know, can do a lot more, which is nice, they're not going to be the weak point. This is Cat 3. So, okay, so Cat 3 is, and CE on the front, which is pretty standard. You know what, did I point out? This has a rubberized texture on the sides kind of built in, and rubberized corners. So it's really grippy. I noticed that when I grabbed it. Just felt really grippy. Looks like a pretty tight seal. Like I say, this thing is really rugged. And these little feet are somewhat soft. Just 2 on that end. Alright. So let's put a battery in. Okay, so I loosened up the battery compartment. And I was going to open it in front of you guys. And the screws are not captive, which is generally the case. I rarely see a captive screw. Wow, look at this. They do put the inserts, the metal inserts into the plastic. Nice touch. And also, first sign of safety is that the battery has its own compartment. It has just a small window where the wires go through and no electronic circuit there. And the two fuses, they're both ceramic. As a matter of fact, I can see a UL listing down there. This 200 milliamp, I can read it, and this one has to be the 10 amp. But they are separated, and just looking down inside there, they have their own little compartments. I can see the circuit board underneath them, but I don't really see any or very little trace and no circuitry around them. So, okay, that passes the first test of safety, right? Individual compartments, separated from other circuitry. Alright, I've removed the 4 screws right here, and we're just going to open it up. I'm going to open it up in front of the camera so you can... Okay, it's not a little bit snug, not super snug. Let me feed this guy through here. Okay, so look, it does have the tongue and groove. You see the little slot? And this is fairly deep, so it does, you know, that's good for sealing in, containing things in case of rupture or whatever. Now that's kind of an interesting shunt right there. It's kind of bent over. It's to get enough length without, you know, taking a lot of space. Very rigid. Okay, these guys seem to be put in with it looks like rivets. They look pretty snug. Looking down inside the barrels, I can't tell. The barrels almost look solid down inside there. Hard to tell, but they do look solid. The plastic is pretty tight around them too, so that gives nice support. Not worried about that. Okay, we got some through-hole resistors to give some power instead of the small surface mount through-hole diode. That's interesting because adding through-hole to surface mount is not cheaper. These little diodes down here are the round, you know, type diodes. So they're called MELF, or referred to as MELF parts. Generally are fairly large in power for the space they take on a board. Okay, we actually have a trim pot, and that looks like a thermistor there. Okay, I propped that guy up, and it's actually a 1 kilo ohm thermistor, so a PTC. Bend it back over. So that's interesting. It's a high resistance PTC. Alright guys, so what I've done is I've loosened these 4 screws here, and I kind of pushed on the display a little bit, and I felt it give a little bit, so I was hoping that I didn't have to remove the screws from the display. And it turns out, because there's so many screws in this thing, it turns out that these 4 are letting me take it out. So okay, looks like one of the buttons came with me. Leave that guy there. Yep, there's the other guy. Well, really no circuitry. Now I do see some vias inside the tracks. If you're doing a lot of, you know, switching back and forth, you could get some wear on the vias, but yeah, for an inexpensive meter, and there's so many tracks close to each other, they would have had to make the meter bigger to put the vias off the side, so I guess that's why they did it. Before I squeeze it back in, I just wanted to point out that these are solid posts. I mean, they're pretty rigid. They look like this weld back here is really rigid. They're not loose at all. So one thing about protection, I'm not sure. I see a MELF diode here. I see a bunch of diodes in this thing. Like this little diode right here. And without bending them over, I can't really tell. And then there's these 2 little diodes here. Which are interesting because they have a DA designation. Those are the only ones with the DA, so they might be some kind of TVS diodes for So they might be just protecting the electronics up here. This one says DP2. There's a little transistor there. So yeah, you know, passes the UO agency testing at category 3. Looking pretty fairly simple. You see the case acts like a nice barrier system. Decent sized PTC up here. Other than that, not a lot going on, but it passes UL. Okay guys, so I think we're ready to turn this thing on. Now I've got it on its stand. The stand has a little flex side, but when it's, you know, it's fairly rigid. Anyway, it's nice and easy to pull out too. So yeah. Okay, so let's see. Let's turn it on. Here, let me put it down so you can see it. Yeah, those nice little rubberized things grab the mat nice. Okay, you know what? Let's hit the backlight. Can you see that? Here, let's turn off the light. All right, there you go. So, Alex, that's not bad, right? I've seen worse for sure. Here, I'll leave it on, see if the timer turns it off. Okay, meanwhile, you know what? Let's just check something right now. Whoops. You know what? We're gonna use this other meter for. It's a big guy, so let me get the picture here. Okay, what we're gonna do is I'm gonna test the voltage on the diode check just to see if see what it does actually put out. Okay, 2.5 volts. All right, and then let's pull over our little friend and put that on diode. And I don't see a way to select, but I think it just automatically selects from resistance to diode. And does this have a backlight? Yeah. Okay, so there's its backlight. We'll leave them both on just to see what happens. And that's almost 3. 2.5. So, you know, most diodes are going to turn on. You want at least 2 volts. There's certain diodes, LEDs, you know, silicon carbide diodes that need a couple volts, high voltage diodes. So 2.5 volts is going to turn on most diodes, and 3 volt, you know, this is near 3. I do have a fluke that goes to 5. That's amazing. But around 2 or 3 volts is pretty standard, and this backlight's gone off. This one's still on. Okay, meanwhile, I'm going to instrument them up so that we can see this one. I want to use this one because it has 5 digits. So we're going to wire all these up and check them out. All right, guys, so we got 1.102 volts, and look at that. I'm in the 2 volt setting on both these, and they're pretty darn close. Okay, we're going to creep up to 2 volts. Now you can see how fast they change. They change pretty quickly. Okay, now see, once I go over 2 volts, now let me creep back down. Okay, as soon as I go to 2, so this is really a 1999, right? They just call it 2000 count. So, you know, it's easier to say 2000, right? But it's always made me wonder a little bit, honestly. Okay, now see, I have to go to the next one. So if it's 2 volts, see how this one's 1.9856? And I've checked this one against my Fluke 5-digit and my Keithley 7-digit. And so they're all pretty close. So these guys, yeah, it actually took a moment, and it seemed like they kind of all dialed in. Okay, let's go up. I'm going to just turn the dial kind of quick and see what happens. All right, let's go up a little higher. Okay, I'm going to kind of go quickly up to 20 volts. Well, 19 volts. Okay, see, that's where they switch over again. Then you have to go to the 200 volt setting. Okay, now 0.55, this guy, that's funny. It's trying to. I think I still got the plastic coating on that display. Maybe when I took it apart, I got it stuck underneath. Okay, anyway, yeah, so this one's pretty close. It should have rounded up to 0.6. And this one, I'm just going to nudge it and see how they round. See this one right here? I'm just checking to see when they actually round up. Okay, that one's trying. Okay, right on the threshold. This one's gone up to 20.5. So that's kind of what I mean as far as you know, the number of digits. Right now we have 3 digits, not 3.5. So that range selects makes a difference. Okay, and notice on the AC they only have two ranges, 600, 200. Oh, and by the way, I had these cables coming from the power supply coming up here. In case, probably, sorry about that. You probably caught on to that by now, but yeah, so that's coming from my power supply, and then I have the probes here for this guy, and these two guys are just tied together with some short banana to banana jacks. So, you know, 10, 20 amp cabling, it's short, and we got high impedance for voltage, so I think we're fine. Alright guys, let's check continuity. I'm going to put this down in to, and just, you know, this meter's older, it's a little bit looser. This one's nice and crisp. It's brand new. So, yeah, you know, one thing about this is most probes are common in the middle, voltage on the right, current on the left. That's kind of what I've been used to. This one was interesting because it was common on the left and voltage in the middle, and then current over here. So yeah, just a different layout. I haven't seen that. Just wanted to point that out. Now, yes, you see ProbeMaster leads there, but no, I'm not using ProbeMasters. These came with my Habo test, and these came with this meter, the Amazon. Okay, here, let's go ahead and just test the. I always think it's funny when I see people doing this, like they're going to start a fire or something. I've never seen continuity test done like that. So, if you're going to do a continuity test, you purposefully touch something to see if it has continuity, right? Sounds like a good continuity tester to me. If 30 ohms, under 30 ohms is continuity. Now this one sounds sick. Alright, I hear you guys. Try the ProbeMasters. Now, the reason I don't test with ProbeMasters is that's a $20 lead set right there. Yeah, it's got gold tips, gold everything, but you don't need that. Yeah, I don't think it had anything to do with ProbeMasters. I think it just has a sick sound. Alright, so let's do a little diode checking. I've got the leads to this guy right here, and I've got this nice big Schottky. So I'm going to put the plus on the anode and the minus on the cathode. Alright, about 2.58. Let's use the Amazon. Okay. Okay, so that's interesting. They don't put a decimal spot, but that's 0.219. That's interesting. They don't put a decimal spot on the Amazon one. Okay, so that's the Schottky. Let's try this bridge rectifier. Now, if I go to the plus pin, there's the AC. The opposite corner is the other AC, and the opposite corner of the plus is minus. That's typically how they're laid out. So if I go minus on the plus, then I should be able to go to each AC one and see a diode. Okay, that's 0.556. 0.533, and then I should see 2 diodes. 1.3. It's funny that they don't put a decimal point. That's got to be 1.3. That's kind of interesting. Okay, let's do this guy. Put the minus on the positive. 0.658. It's a little bit higher like it was on the Schottky. Yeah, so it depends on how much current. I think I read this puts out 1 milliamp test current. So I'm curious, like, you know, what's going on here. Okay, let's do an in-circuit test. Okay, got the leads for the ByteTech here. Okay, let's get forward biased. This is in circuit, about 0.6. If I reverse it, let's see what happens. Since it's in circuit, we're not sure. Looks like it's charging a capacitor. Okay. Let's get this guy, the Amazon, and let's see. Okay, it was that other one charged up a capacitor, so the Amazon's draining it. I guess I should have shorted the leads. Okay, so that must be 0.526. I think it's interesting they don't put the decimal point. I guess you gotta spend another $1. Okay guys, we brought the X-Tech back in. I'm running the positive out to the microamp input, and I've got the return here, and I've got my probe coming here now. So this way we can measure the current going into the diode. Okay, it's 912 microamps, so not quite a milliamp. And look, this went up a little bit, 784. There's a little bit of resistance inside here to, they call it burden resistance, to so the meter can actually measure voltage drop. So I think that's why that went up. But okay, let's try this guy. Alright, so now I've got this meter going over to the microamp, and the return in my hand, it's the red lead and the black one. So anyway, now we're going to measure the current from that guy. 800, so it's a little bit less, and the voltage over here on the right, it's a little bit higher. So yeah, I think the test current's just a little bit different. That's why we're seeing different voltage drops. Okay guys, so here's what we have going on. We have the power supply right here, this lead and this one. Okay, so it's going into the 10 amp terminal of this guy, the Amazon meter. Then the Amazon meter comm comes out and goes to the plus of this guy, and then the comm comes out and goes back to the power supply. So it's just series. So now we can bring up both power supplies. Okay, right now I guess I must have around 150, 160 milliamps. So I'm in the 10 amp setting. Okay, and I'll bring up the current so we just see how they read. Okay, 3 amps. Okay, I'm going to stay under 10 because I don't want to blow out the fuses, but yeah, there we go. So you can see there's a little difference in the accuracy. Alright, so now we have the Greenlee, so we can compare the Greenlee, which is a really accurate meter, to these two guys. Right now, it looks like they're reading pretty close to the same number. Alright, let's get real close to 1 amp. Okay, there's boy, the Bite Brothers seems like it's pretty darn close to the Greenlee. Alright, I don't want to take it too high because I don't want to burn out their fuses, but there we go. So the Bite Brothers did seem like it matched the Greenlee closer. This guy was, you know, it's only a decimal place off, but between the accuracy and the 2-digit in the 10 amp range, it's 2 digits, so it's counted 2 on this side, and then it's the tolerance, which I think was 2% for these meters at 10 amps. Alright guys, so this is an example of, I got them both at 20 volt. We're going to read a 9 volt battery. 7.19. I'm going to move these guys over here. .16 or 5. It's kind of dropping. I think the meter is discharging the battery a little bit, but that's the point. Check this out. Put it in battery mode on a 9 volt, and it puts a little bit of load on it. And look at that. Makes all the difference. So a battery will kind of peak charge. Even the high impedance at 20 volts was leaking off a little bit, but look how fast that shows the real charge on this battery. So that's what the battery modes, and it has a 1.5 volt level too. Alright, but what about something in between? Here's a 3 volt battery, so I think if we're in the 9 volt range, we should be good. Let's go ahead and, you know what, let's go first over here to 20 volt range, and let's test this battery. Let's measure it. 1.66, 3 volt battery. That's obviously bad, but let's go over down to the 9 volt range. Wow, look at that. Under a half volt. Yeah, that bad boy's been sitting in a meter for a long time. Okay, I grabbed this Duracell. Here, I'm going to go back to the 2 volt setting. Up here, let's check it out. Swapping leads doesn't really matter, right? Now look at that. That decimal point is missing. You know what? That thing I think is just missing on this meter. I think I'm missing a segment. Keep on sliding off. 1.54. Okay, let's go back over here. You know what? This battery right here is not too bad shape. It just dropped a little bit. Keeps on rolling away from me. Here, let's see if I can hold one terminal down to keep that thing from rolling away. That looks like a good battery still. I thought that was a bad one. I have to keep that one. Battery measurements. I think that's a nice feature. Da-da-da-dong, dong-dong. Enter X-Tech. Guess what? This guy has a insulation tester, 125 up to 1000 volts. But it goes in, it jumps, so I can't hit every voltage in between. I can go 500 volts though. So let's turn this bad boy on. And you put plus there, minus there. And then I'm going to go between my plus and my common. Alright, so what we're going to do here first is hit the AC. We'll start at the 200 volt range. We'll just test it out. Now all I have to do is see I'm at 500 volts. And this is the measurement voltage. You're going to see a voltage pop up there, whatever I'm measuring. And then the resistance, whatever it measures for resistance, is here. This is an insulation tester, a lot like a high pop meter. Or a Megger, you might have heard. Those are kind of brand names, or trade names. But this is a insulation tester. Okay, so we're going to apply 500 volts. Oh, look at that! It only put 13 volts, and look, it was only. I'm down here in 20K. Oops. But I think the meter is fine. Okay, so that little black arrow didn't stand out enough, but yeah. And it's also a little bit narrow on this end. Okay guys, so we're set up for the 200 volt. We got 500 volts set. When I push this button, it's going to apply the voltage, and you're going to see the readout here. And AC wise, this is a DC voltage tester, so you're going to see the mega ohms, whatever it measures here. Unless it breaks down, then we're going to see something less. And it beeps to say, hey, we're testing high voltage, and then it applies it, 520 volts, and 444, or 0.44 mega ohms. And that's an overload. It's saying, wow, that's too much voltage. But it's fine, it didn't hurt anything. Okay, let's try there. So I exit. And then I try this one. Alright. Well, it said overload, but it's 520. It should have. Oh, it's because it's AC, so it probably spiked up. But when I let go, it holds the measurement. 520 volts. 0.44 meg, same thing. Meter's fine. So, you know what, let's start at 200 millivolts. Let's just try that setting. Exit. There we go, 521 volts. It's got the little lightning, the high voltage symbol blinking, the beeper's blinking at me, and meter's fine. It is just over range. And now this guy starts to bleed off the voltage as you let go. So I'm going to exit it. So you can see he's bleeding off that voltage that he applied. Okay, now we're going to put up to 500 volts, and this one, it's up to 600 volt range. We should see a measurement this time. Okay, ready, set, go. Okay, there we go. 524, 528, pretty close. And look, it's almost a mega ohm. So, yeah, it looks good to me. So, this meter is good up to 500 volts. Now, for AC, you would consider that peak. So you divide that by square root of 2, the 520 volts, whatever the test was, and that would be the max AC equivalent. Okay, let's come over here, common, and volts. Okay, yeah, well, you know what, let's just start off the 20 volt range. This guy kind of beeped at me, but it's fine. That was interesting. Okay, let's go to the 600 volt range. Whoops, exit. It's reading the voltage. There we go. That's pretty darn close to this one. And 980, almost a mega ohm. So that looks fine too. Yeah, looks good, guys. Let's do the AC. It's got the same two ranges. I'll just do the 600 volt range. So it kind of pops up at 520, and that's funny. It thinks there's an AC voltage of 1100 volts. But it's fine. No problem there. We got 0.44 meg. You know what? I'll turn on the backlights again. So this backlight's pretty bright. This one's pretty even. This one's nice too. You know, it's without the lights on. I mean, this one's bright in daylight, but I wonder how much juice that's bringing. But he's also got a timer. See how fast he goes off? This guy does not have a timer, so some people will like that, but that's going to drain batteries fast if you leave it on. But I kind of find it annoying when they turn off, especially fast like that. I kind of want them on longer. So anyway, trade-off, saving battery or having to remember to turn it off. I like this little guy. He is the Amazon commercial 90DM120. UL rated, so you've had another party test this. And this guy here is the Byte Bros BBT858L. Now this is an older meter. I bought it used. I got it, as you guys may have seen, a Multimeter Bonanza. I'll put the link below where I got this with some other meters. But it's nice too. I would trust using these meters for any AC or DC voltage on my bench or coming from the wall. So yeah, inexpensive, nice. They're both nice. You know, this guy here doesn't have the rubber holster, but I like the rubber grips. Like I've said, nice meters. This guy here has a problem. It's missing that decimal though, right over here. See when I move this? It just doesn't have a decimal right here. See right there? It should move the decimal right there. So it's, maybe if I took it apart, I don't know. I'm going to send it back to Amazon since it's new. But yeah, it's missing that decimal point right there. Yeah, it could be that, you know, these are new meters and they might have some bugs, or maybe I just got a bad one. But it's no big deal, even if they didn't take it back, which they will. They're Amazon, but and I haven't had it long enough that, you know. But yeah, when I go there, I should have that decimal point. So we've kind of missed that in some of the tests, and I think I finally figured out that I'm missing that decimal spot. I'm actually impressed with both these little meters for, you know, under 20 bucks, under 15 bucks. Really impressive. I guess I'm really just amazed at this because I can't believe they spent money for UL agency for a meter that inexpensive. But because it's Amazon, I guess they probably worked out a deal where they get the whole range of meters, all UL approved for some kind of price. Who knows? But that's a really cool deal. All right. Hey, what do you guys think? Are you impressed with this little boy? I'm impressed. I mean, wow, it's a small meter. I mean, for anybody that doesn't want to spend a lot of money, stick a meter in their car, you know, in any kind of tool bag that you might just want to have an extra meter. God, that's just inexpensive. And with the UL listing, you know it's going to be safe. They're not going to list it unless it was. So anybody that's, you know, kind of leery about the safety stuff, watch my other video on safety, okay? And always be safe. But gosh, this guy here, I love the rubberized sides on it. It just makes it real grippy. Rubberized corners, and it's so lightweight. I think you could probably bounce it off the cement here and probably be okay. But I like this little guy. What do you think about the voltage test? Do you like that? I'm going to start doing that just to make sure they all pass the volt test. But alright guys, hey, give me your comments. Tell me what you think. And if you want me, I'm really curious about some of the more expensive Amazon commercial meters. Hey, thanks Patreons for helping me out. That's gonna help a lot. This does get expensive doing this stuff, but thanks Patreons, I really appreciate it. Thanks everybody for watching. Give me the thumbs up. That really does help the video. Helps the channel. And subscribe if you haven't done so. And let me know what you guys think. Let me know what you'd like to see. And the good, bad, the ugly, all that stuff. Okay? Thanks for watching, guys. See you next time. Wow. Impressive.